Dear experimental archaeologists, it is a pleasure for us from the Laboratory for Human Evolutionary Studies in the Institute of Biosciences of the University of São Paulo, Brazil, to be here presenting a little bit of the experiments we have been carrying out. Studies using experimental archaeology in order to further understand the cultural evolution of prehistoric human societies in Brazil have been so scarce, especially on lithic and bone tools. Our laboratory has been interested in investigating the changes throughout Holocene in archaeological cultures from southern Brazil, with focus on early hunter-gatherer populations. We're getting to better understand the role of cultural transmission, population parameters, as well as environmental changes in the evolution of artifacts and landscape occupation of these hunter-gatherer groups. In order to do that, we have combined two complementary theoretical approaches, evolutionary archaeology and experimental archaeology, in order to unravel patterns and rates of change in Paleoamerican sites or groups of sites. Our experimental studies focus on the raw material sources of lithic and bone artifacts, as well as on the chain opératoire related to the manufacture, use, and discard of such tools. The experimental data can be analyzed in combination with the results obtained from morphometric and technological analysis of the archaeological materials, showing that a greater knowledge can be obtained when actualist studies are incorporated to the analysis of lithic and bone artifact making and use in the past. Originally, we would present here the results of the experiments we made by replicating artifacts from two Pan-American sites from southern Brazil, Tunas and Garibaldino. However, we realized that in order to better demonstrate how the experiments of our research team are being carried, we decided to show some of the experiments that are also being applied in assemblies from other Brazilian sites associated to hunter-gatherer groups as well. This decision was made based on our desire and effort to develop the experimental archaeology approach in our country. That is still done by few researchers, but also to show that these experiments may be applied in many different cultural contexts. Our first example comes from the Garibaldino site, the holotype assemblage for definition of the Garibaldinense culture and the Garibaldinense type point, dating back to 12,000 years ago. This experiment is also related to the replication of bifacial stemmed lithic points. The experiment is also being carried out in other point types, but here we have a good example of how experimental archaeology allowed us to distinguish bifacial preforms from finished points. When Brazilian archaeologist Pedro Mendes Ribeiro described the artifacts from the site for the first time in 1999, he included hundreds of unstemmed bifacial artifacts that he identified as lanceolate or foliaceous points. These artifacts have never been studied in technological terms by him or any other researcher, but we have recently carried out the following studies: a detailed analysis of the stemmed points technology, an experimental replication of the points, and an analysis of the foliaceous points from the original assemblage, and the preforms that came out from our experiment. These last results are still in press. However, we anticipate that our conclusion on this experiment is that those artifacts are not finished points. They are actually preforms of the bifacial Garibaldinense points. They are the points that, for distinct reasons, were not finished. Although some of the preforms were clearly abandoned due to accidental fracture during knapping, the metrical analysis shows that many of the unbroken ones are the result of knappers that failed to get the right width-thickness proportion. And when we say the right proportion, that is because this is a very standard feature of this type of points, which is not the same one observed in other ones, like the star-type points found in the previously mentioned Tunas site, for example. What happens in these cases is that preforms, when its bifacial reduction is finished, they must be wider than the finished retouched and stemmed points, because retouch is still going to happen, reducing the width but not reducing the thickness. So, if the preform is not thin enough, the points are going to get too thick after retouch. And depending on the thickness, retouch by pressure flaking in some of these Brazilian silicified sandstones may get too hard to accomplish, resulting in preforms and points like this, followed by much pain in the finger joint. This is not the only aspect of lithic technology that experimental archaeology obligated us to review our previous concepts. A second one that we can mention, among others, is the difference between the attributes of flakes removed by both hard and soft hammers. For many decades between lithic technology experts, especially by the ones without experience in flake knapping. There is a rumor that it is possible to identify if a flake was produced by hard or soft hammers, just by observing their cornices and their bulbs. According to this concept, if the flake has a permanent cornice, a lip, and a diffuse bulb, it means that the flake was produced by a soft hammer. But if the bulb is permanent and the cornice has no lip at all, it means that the flake was produced by a hard hammer. This supposition was only taken as a hypothesis by few experts around the world, including 2 Brazilian studies. The first Brazilian study was led by our dear colleague Dr. Maria Jacqueline Rodet and published in 2004. Rodet and his colleague applied both techniques in high-quality flint from the Paraçu Valley in Brazil and compared the flake's attributes. The results supported that hypothesis. The second experiment, carried out by João Carlos Moreno de Souza and published in 2019 in the Exert Journal, also supported that hypothesis in the case of the replication of points and scrapers associated to the Rio Clarence culture, materials typically made on high-quality flint. However, when it was the case of, once more, the Garibaldinense points, usually made on silicified sandstone, basalt, and agate, the results did not support that hypothesis. In fact, the experiment shows that when the raw material is not so fragile and homogeneous, the features of the flakes may get different patterns, or even no pattern at all, with unpredictable features. In the case of the silicified sandstone found in the Garibaldino site region, it is impossible to suggest which technique hunter-gatherers were applying to reduce their preforms. But we know that retouch was systematically made by pressure flaking, not just because we can observe high precision in this flaking stage, but also because pressure flakers, specially made on antlers, were found in the same context. Jacques Texier, French archaeologist that has experience in flake knapping, in one of his best works, noted that the recognition of flaking techniques isn't that obvious in flakes and artifacts, since their features may present different patterns in different raw materials, and some features might be exclusive of materials with certain physical characteristics. In this sense, archaeologists might get surprised with the results of experiments applied in a high diversity of raw materials. Experiments on artifacts made on bones and antlers are rarer in Brazil than the lithic ones. This happens for 2 main reasons. The fact that few researchers have analyzed the materials in their assemblies, but mostly because the raw material is harder to get than people may think. When replicating archaeological artifacts, we need to use bones and antlers from the same species people used in the past. However, since many of these species are in risk of extinction, especially the Brazilian deer, hunting is prohibited and acquiring donations is difficult. So, the most common way of acquiring this material is by finding the dead animals yourself or getting from someone that has. So, much of the bone and antler experiments are made using analog materials, like antlers from similar species or bones from other species that present the same shapes and density. Here we show an experiment of replication of bone spatulas found in many different cultural contexts of Brazilian early Holocene hunter-gatherers, like in the highly mentioned Garibaldino site, but also in sites from the Lagoa Santa region and the Serranópolis region. In this experiment, we used a single metacarpus of a sheep. Sheep are non-native animals from Brazil. However, their metacarpus bone is very similar to the Brazilian deer's metacarpus in many aspects, including shape and density. This is an excellent analogous material to work when deer metacarpus is not available, and much easier to acquire with local farmers and butchers. This experiment was made in order to test hypotheses related to the high use of deer metacarpus used as the main raw material for hunter-gatherers in South America. In many archaeological contexts around the world, spatulas were also made in metapodial bones from ruminant mammals, presenting rounded tips and not sharpened edges. However, its function is unknown in most cases, with few experiments related to their use, mostly concluding that they were used for smoothing dry hide. In Europe, many experimenters produced bone tools by controlled fracture, in which the breakage areas are limited by indentation made by a sharpened lithic flake. These areas are easily broken and avoid the fractures to expand to areas that would compromise the artifact production, avoiding errors and raw material waste. To make this artifact, we used a sheep metacarpal found in 2013 in Castelluccio, central Italy. The animal had already lost its soft tissue, indicating that death had occurred some time ago. The bone was already dry, showing longitudinal fractures and a whitish color indicating weathering. This bone was kept in a small box for 6 years, when, due to the lack of another type of raw material available for further experiments, it was used in this experiment. At first, we tried to fracture the proximal epiphysis in the direction of the bone axis with soft percussion, because due to the fact that the bone was already dry, it seemed likely that it could break in half. However, it was only possible to weaken the region without creating a complete break, which was ended with a pebble in the weakened area. The region of the proximal epiphysis broke into strips, which were used later for making 2 arrow points, but still it was not possible to reach a satisfactory preform. To open the bone, we exposed the medullary canal and delimited the area to be shaped by polishing. We used a small deer antler. We introduced it into the medullary cavity of the bone, and with the help of some percussion on the antler, this cavity was enlarged. However, the fact that we didn't control the fracture by making vertical indentations in the bone, the fractures on the metacarpal could not be predicted. The result was that we got a twisted preform, but we carried out on to finishing the artifact anyway by polishing it. The polishing was done dry with the help of a friable sandstone type block, a polisher. This type of material is usually found in archaeological sites with polished artifacts. Its coarse-grained sides facilitated the polishing and finishing of the artifact. 2 different movements were made to polish and format the bone. The first movement was continuous, back and forth. The second movement was unidirectional. The results showed that the second movement proved to be more effective regarding the polishing and firming of an edge, if necessary, in the artifact. Horizontal movements were made at the tip of the artifact in order to remove a little bit of its thickness. If we compare to the archaeological spatulas found in the Garibaldino site, we see that our replication did not get the way we wanted it to be originally. However, although the replicated spatula is not perfect, mostly because of its twisted aspect, it's only by doing this type of experiment that we understand why this other spatula found in the Diogo Lemos site in the Serranopolis region looks like this. We choose this example with a specific type of artifact, but many other examples could be replicated, such as hooks, bone pendants, pendants made of teeth, bones, as well as needles, and etc. Since bone artifacts are mostly made by polishing, inferences about their technology require the application of replicating experiments, even more than flaked tools. But even on the flick napping, we could show many more examples of how replicating experiments helps us to better understand ancient technologies. And this is why archaeologists should have a minimum of experience in producing artifacts themselves. They change our interpretation on ancient technology right after our first experimental activity, whatever it is. Although the experiments carried out by our research group related to the lithic and bone industries are still under development, the results from both simple and systematic experiments have been allowing us to reflect on the importance of the experimental archaeology approach. Unfortunately, experimental archaeology is not yet a consolidated research line in Brazilian archaeology. Few studies have attempted to understand, through experiments, the technology of artifacts associated with hunter-gatherer groups in a systematic way. However, it is necessary to consider that, although they are few, these studies influence the interpretations generated on the archaeological record. Therefore, we consider the development and spread of knowledge about experimental archaeology in our country, but also in all South America, are necessary and urgent. We hope that with the continuity and growth of experiments and with more methodological discussions, and hopefully more meetings like this one, experimental archaeology will finally consolidate itself as a line of research in Brazilian and South American archaeology. If you want to know more about our research and experiments, feel free to contact us. Cheers!